I forgot what page it is, like I always do. 62? So this is going on page 62 when we're done. Okay, so again, we're going to sketch them. We are not even going to worry about having enough information to get it everything about it perfect, because there's certain things that we're concerned with, there's certain things that we're not so concerned with, okay? So here are the steps. I'm going to kind of talk you through them, and then we're going to go through and do some. But you've got to find the x-intercepts, which is really the zeros. Find the y-intercept. X-intercepts is plural. Y-intercept is not. Should the y-intercept be plural? Am I going to have more than one? No, not if it's going to be a function, right? So notice if the polynomial has even or odd degree. So it says even or odd degree. It does not mean is it an even or odd function, okay? Because that may not be, and that doesn't matter. But it's just whether or not it has an even or odd degree, okay? Notice the sign of the leading coefficient. We want to know if it's positive or negative. And determine the end behavior. We'll look more at end behavior here in just a second. Notice if there are factors with a degree higher than 1, okay, because there'll be some that look like this. So that particular factor has a degree of 2, right? So when even powers factors, they give you a relative min or max on the x-axis. Basically, it bounces off the x-axis. Bounces is what I was trying to write. Bounces off x-axis. Okay. Odd power greater than, see, there's a mistake right there. Greater than on doesn't make any sense. 1 locates a point of inflection on the x-axis. So let's talk about point of inflection real quick, because that's not something that I think, well, it's not something we've covered this year. I'm not so sure that's something that you've learned before. A point of inflection is where it changes from concave up to concave down or vice versa. So it's going to look like this. Like that is a point of inflection, like on a cubic. Okay? Because here it is concave down and then it is concave up. So this is a change of concavity. It's easier to say that than concave up to concave down or vice versa. It's just a change of concavity from one to the other. So it looks like what you're thinking of a cubic function looks like at the origin or the parent function. All right, and then we draw the continuous curve, and here's what we need to observe. We observe proper behavior at each zero, y-intercept, and end behavior. We don't necessarily know what the actual max and mins are, and that's okay. Okay. So let's talk end behavior. If we have a positive leading coefficient, and it is an even degree, you can think quadratics, okay? Just kind of have a quadratic in your head. That doesn't mean that, they're all exactly the same, but have a quadratic in your head. So if I have a parabola and I have a positive leading coefficient, what does it look like? Show me with your arms. I have a parabola with a positive leading coefficient. Everybody do this. Come on, put your arms up. Put your arms up. Woo! All right. So I'm not saying that the polynomial itself is going to look like a quadratic. What I'm saying is that the end behavior of a positive leading coefficient with an even degree is going to look like this. So this is what we draw here. I have no idea what's going on in between, but it's going to look like that on the ends, because we're talking end behavior. So the limit of the function as x approaches negative infinity is going to be what? The limit as x approaches negative infinity is infinity. Good. And then the limit of the function as x approaches infinity is going to be what? Infinity. Everybody okay with that? Right. Even degree. We're still thinking quadratic, right? Negative leading coefficient. What's it going to look like? Show me with your arms. Everybody. Come on. It's going to look like this, right? You go. Do it. Do it. You got to yell? Both arms. Okay. Good. So it's going to look like something like this. Okay. So the limit of f of x as x approaches negative infinity is what? Negative infinity. And as x approaches infinity, negative or positive? Negative. Heard you second guess yourself there. Okay, we good? Now, with an odd degree, you think cubic. Okay? So think about what a cubic function looks like. And if I have a positive leading coefficient, what's that going to look like? It's going to look like, if I'm drawing it, right, it's going to look like this. Right arm up, left arm down, right? So for me, if I'm facing you, it's like this. So your right arm up should be up. Right? Everybody do it. Right arm up, left arm down. Okay, good. All right, so it would look like this, right? Because we don't know what's going on in between. Just like that. So the limit of f of x as x approaches negative infinity is negative infinity. Limit of f of x as x approaches infinity is infinity. So odd degree, negative leading coefficient. Then what's it going to look like? Show me. The opposite, right? Everybody show me. George, we're waiting on you. Like this. So the limit of f of x as x approaches negative infinity is infinity. And as x approaches infinity, negative infinity. Okay. Everybody good with that? So that's in behavior. You need to think about what it's going to look like, right? So let's go do some of these. And have your list there. I'm going to give you this. I'm going to give you another sheet of paper that is like, and the only reason I'm giving you this, you don't have to glue this part in or anything, but it has the list of stuff that's on the front. That way you don't have to flip back and forth. So just, and when you're done, we can just recycle this and that's fine. Because it says the same thing, but that way you're not having to flip back and forth and you have something to refer to while we're going through it. All right. So the first thing we're supposed to do is find the X-intercepts, which are the zeros. X-intercepts, okay, officially, when you were asked for the X-intercept and the Y-intercept, when they're asked that way, they're supposed to be ordered pairs. I don't feel right saying, oh, I'll accept either one, because I will take your watch from you, just like I'll take your phone, sweetheart, so you best get off that thing. Anyway, so I don't feel comfortable saying I'll take it either way when it's not always going to be counted right. So where it says X-intercepts, and it says it on your notes, and it says it on your homework. So I left it like this, so on your homework I want you to do the same thing. I'm just going to mark that out, and we're looking for the zeros. Well, if you call them zeros, roots, solutions, all those other things, they can just be numbers. When it's an intercept, it's really supposed to be an ordered pair. So I don't want to, notation and being correct is important to me for real. So we look at the zeros. So we have this, right? Is it easy to figure out what the zeros are? Yes. Because this one would give me a what? -1, 3, -4. Okay, so we're going to list them. Let's see, -4 is the smallest, then -1, then 3. So there are zeros. How do I figure out my y-intercept? The y-intercept, as an ordered pair, what do we know before we do anything? Do we know the x value or the y value? The x value. So isn't the y-intercept always what is y when x is 0, right? So if I plug in 0 for x, okay, so if I want to find f of 0, that's going to be 1 times a -3 times 4, right? Does that make sense? So what do I get? -12. Everybody understands where those numbers came from? Because if I plug in 0, would I do that wrong? No. When I solve it, it has nothing to do with these. Yeah. It has nothing to do with these. You're right. When the value of, yes, my 0 is at -4. But when I'm just plugging it into this right here, this would be like, this would give me 0 plus 1 times 0 minus 3 times 0 plus 4. So you do not take these and multiply them together, right? Don't do that. It's basically doing this, so you just ignore the x's and do whatever you see here. Does that make sense to you? Because we're finding what x or what y is. So it is at negative 12. Now, we don't really, scale is not super important here. I mean, it is, but the x and y scale clearly doesn't have to be the same. You don't even necessarily have to put little hash marks on the y-axis. It is at a negative 12, so I'm going to put it down here. Let's just go ahead and graph it. So I'm here at negative 12. On the x-axis, you probably want to make a few hash marks just to try and get things. We should never be making thousands of them, because if so, then we just need graph paper, but this will get us what we need. We'll do like 5 each time. And then I'm going to plot my zeros. 1, 2, 3, 4. This is my negative 4. This is my negative 1. This is my 3. Now, the y-intercept is not necessarily, I think that's how you spell it, not necessarily, I should use a different word, a max or min. It can be, but we don't know enough about it to know. We don't really care. All we know actually is that it crosses at that point. So it could come down and hit at negative 12 and then go back up. It could come down and the minimum actually be down here. We just don't know. Okay, so you could draw it a little bit differently than each other and we could still have right answers. All right, so the degree. What's the degree of this polynomial? What? 3, right? Got 3 x's. So we've got, my degree is 3. And your leading coefficient, is it positive or negative? Positive, right? This is positive out here. Well, I don't really even have a leading coefficient, so it's like a positive 1. So it's positive, and it's an odd degree. So show me what it looks like. Right? And so that's what you draw for your end behavior. You need to think of it, you need to understand the limit part of it, but what you're looking for end behavior is just a little sketch that looks like this. That's it. You don't even have to put the little x and y axis. That's it. We're not saying it looks like a cubic, it just has the same end behavior. We good? Because if I was to actually multiply this together and actually get the polynomial from it, then I'd have x times x times x, which is x cubed. You can really just count your x's. Okay? All right, so now that we have that, we know that it's got to start down here below negative 4, right? And I don't have any factors that have a degree higher than 1, so we don't have to worry about those special cases here. So what's going to happen is, and you want to kind of plan it out before you do it, I'm going to start down here. That means I'm going to go through negative 4, and then I have no idea how high we go. We could go right here. It could go all the way up. We just don't know at this point. It doesn't really matter because we didn't even put anything over here, right? It's going to come down through negative 1. It's going to go through negative 12, may or may not be a minimum, and then it's going to come back up through 3. So I will end up with that end behavior looking like that, and so we just start to sketch it. And I'm going to have to kind of be in the way in order to sketch it because it's not going to look that good anyway. So it's going to come up this way, down through there. I've got to hit the negative 12. I've got to go back up through 3, and it looks something like that. Okay? That's it. We have the key points that we're interested in, the x-intercepts and the y-intercepts, which are labeled with numbers. That's important. You need to do that. Okay? Everybody okay with that? Yes. So yours could look a little bit different than your neighbors. You know, maybe your neighbor stretched theirs up a whole lot higher. That's fine. Maybe your neighbor had this as the actual minimum. That's fine too, because we just don't know. This is all we're aiming for right now. We all good with that? Okay. So, let's look at this one. We'll just start by filling in these blanks and make sure we hit everything else because it doesn't really, these don't go in the same order that the list is. But what's the degree of this polynomial? What do you think? How many x's do you see? Do you see? 3. How many are there really? 4, right? So the degree is 4. Okay, so my degree is 4. So it is an even function. Is the leading coefficient positive or negative? Positive. Show me the end behavior. Everybody, come on, end behavior. Wait, no. Okay. In behavior, good. So we do this. I know, you were writing your notes. It's all good. Looks like that. All right, so then I look for the X-Intercepts, which we want to change this to, this is really our zeros. You can find the X-Intercepts, but then you have to write them as ordered pairs, and I don't really want to do that. So what does this give me? 0. Okay. And then this would give me 2. Do I write it twice? No. And then this would give me 6. Okay. My y-intercept, I know I start with an x value of 0. What would the y value be? 0, right? If you have an x-intercept or a 0, that is 0. Your y-intercept has to be 0, 0, because anything times 0 is going to give you 0. Everybody good so far? All right, so let's go ahead and plot those key points there. We've got y-intercept is at 0, 0. Got I'm here at 2 and at 6. And I know because of my end behavior, it's going to go up here and then down here. I would suggest that, well, I guess it shouldn't matter. You go ahead and draw those in. They both go up. Never mind. I wasn't even, see, I can't even see it. They both go up. Both go up. I'll see if you're paying attention. Good job. There we go. Okay, but we have a special something that happens in here. I think it's number 6 on your little list there. It says, notice if there are factors with a degree higher than 1. Even power of a factor gives a relative min or max on the x-axis. And then what did I tell you to write next to that? What happens? It bounces off the x-axis. So we're going to have it bounce off which one has a degree of higher than 1? 2, okay? So it's this one right here that we're going to have an issue with that we're going to have to bounce off of. So I come down, and here's why I really didn't want to draw this first, but that's why I shouldn't have had you do that. I'm going to erase mine. You don't necessarily have to erase yours. I just didn't make it good enough. I'm going to erase it. Sounded like a good idea at the time. It's not going to help you any. When it comes down, it's going to come down and then have to come back up to 2, but it's going to bounce off and have to come back down. Does that make sense? Do I know how far it comes back down? No, and then it comes back up, and my end is just not good. It's hard to get the right angle. So it should look like something like that, but always better. Yours should always be better than mine. I could do it totally a lot better on a piece of paper. Do you get the idea, though, what it means by bounces off, though? Yes, it still ends up like that. Your end behavior is what it is, no matter what's happening with the factors. That's why you can go ahead and draw it in. I just didn't have mine at a good angle. So if you need to, you can, if that helps you, but it really might depend on what you're trying to do with the rest of it. Okay, we good? And we have no idea. I mean, this could come all the way down here for all we know and then come back up. And so could this, or maybe it's right here. We don't know that stuff based on what we have. Okay? Could we plug it in the calculator and find it out? Yes, but we don't care, so we're not going to. We don't have a calculator anyway. We good? Okay. We're going to do this one together, too, and then I'm going to let you do the last one. All right, so what's the degree of this one? 5. Okay, everybody good with 5? We know how to find that out, right? Okay, so it's odd. Is our leading coefficient positive or negative? Negative, right? So show me what it looks like. Yeah, because if you were to graph an odd, you think cubic, right? But then it's negative, so it flips around, so it should look like this. So your end behavior looks like this. The 1, right now we just have a 1. It's whatever's out in front here. Yes, exactly. Yeah, we're only concerned with the sign. All right, so then our x-intercepts, we're going to change that to zeros. And then I'm going to get positive 3, negative 4, negative 1. So negative 4, negative 1. Oh, 3. Then I want you to figure out what the y-intercept is. What do you get? 108. Because you've got what you end up with is the negative 3 cubed. And you might need to write, if you need to write that out so you've got it, write it out. I'm not saying you have to do it in your head or anything. Plug in the zeros if you need to. But that gives me negative 3 cubed. So that's a negative, and that would be a negative 27, right? But then you take, and this is also negative, so that makes that a positive 27. Times 4 is 108. Times 1 is still 108. So luckily, we don't have to worry about making little hash marks on our y-axis. We just have 0, 108. Oh, and you know what I didn't do on the last one? I didn't write the numbers. We need to make sure we do that. This is at 108. And then we'll go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then I'm going to plot my points. This is at a negative 4. This is at negative 1. This is at 3. Okay, so I know what my end behavior looks like. I know I'm going to start up here and come down through that negative 4. Do I have any of these factors that have an exponent greater than 1? It's the 3, right? So this right here, this is where it's not going to bounce off, right? Because this is an odd-numbered factor. That's where it's going to have the point of inflection, which can get kind of tricky to draw. You don't even want to see my original picture of this. What that means is that at here, right here at 3, it's going to come, since I know I have to end down here, it's going to come down like this and have to change like that. Does that make sense to you? That's what's happening there, and then from there, we're going and doing something else. So we can go ahead and try and get that in there. It's going to look like that. Okay. The other ones, they just cross, and that's it. Okay. So I start, my end behavior tells me I start by coming down through the negative 4. I don't know how far I go down, doesn't really matter. I go up here. I know I have to hit the 108, except I totally missed it. I have to hit 108. It's not necessarily a maximum, so I can come down there and then meet up with it like that. You could make 108 your maximum because you don't know. But if it's got to match your curve, then you can do whatever you need to do to make it match right now. I know these can be tricky, but it needs to be very clear at points like this that you actually have a point of inflection. Okay, so you need to kind of maybe exaggerate that a little bit if your graph is small or whatever. But any questions? Do you understand what it means for a point of inflection, what to do when you have those factors with a degree higher than 1? We good? All right, then I want you to work on the last one on your own. Yes. Make sure when you're doing this that you are not adding extra X-intercepts, no extra zeros there. So let's go through this together. What's the degree? 5, right? So it is an odd-powered polynomial, and it's a positive, so end behavior is going to look like this. My zeros are going to be -3 and 3, right? Now, do either one of those factors have a power greater than 1? Yes or no? Yes, both of them do, right? What's happening at the -3? -3 is it the cubed or the squared? This 0. It's the cubed, right? So this is a point of inflection, right? This is an even one, so this is where it bounces off. Okay? It's either a point of inflection or it bounces off. Then we have to have the y-intercept. We know it's 0 something, and that's where some of y'all got messed up here. When you plug in 0, you're just left with 3 here. So it's 3 cubed times -3 squared. So that gives you 27 times a +9, which is 243. Okay, so we got to get all that right before we can do anything else. So then my y-intercept, it's way up here at 243. So then I can do 1, 2, 3, 4. I've got zeros here at -3 and at 3. You cannot touch or cross the x-axis at any other points besides those two. Okay? So I'm supposed to have a point of inflection here. I know from my end behavior that I start down here, right? So I've got to come up and it's got to have a point of inflection looking cubic-like, right? So for me, I've got to kind of draw it in at that point first or it's never going to look right. So then I'm coming up. At some point I have to come down. At some point I have to go through 243, whether it's a maximum or not. Now when I'm heading back, and you see how mine kind of bumps out a little bit right there? It really shouldn't do that because then it's not a function. So let me make it a little bit better. Now when I go down, am I going to cross at 3? No, it's going to bounce off of 3 and come back up because my end behavior is supposed to look like that. So do you see how you make the little decisions at each little point? It's not going to be something where you can just go, oh, I'm just going to draw it like it's a parabola or something. You got to think about each little part, making sure that you're not crossing or touching the x-axis at any extra parts. That's why you want to go ahead and plot the points first and number them so you can make sure you're not using anything extra. Okay, are we good? All right, grab your homework. I got to have you fix something. I want you to look at number 9 first. No, nothing wrong with number 9. Number 10 is the one we need to fix. So on number 10, where it says 1 minus x, this should change that to x minus 1. And then on 12, what are you going to need to do on 12 before you can do it? Factor it. And this is a quartic, but you can start by factoring it just like it's a quadratic, and then you get 2 quadratics and you can go from there. You're capable of it or we wouldn't give it to you. Okay? We good? But you got to factor this one first. So factor first. Okay. Everybody good? Any questions? All right. So not necessarily great works of art, but it needs to be clear what the point of inflection is, that your points are actually numbered on what you're doing. Okay? So it's clear. All right, good deal.